So today's discussion is a very brief talk on cardiovascular system, the heart of the matter, or the heart of the body, and the heart. Heart as an organ is by far the most important vital organ of our body. It creates a circulatory system that feeds and enables every tissue, every living cell in our body to become alive and be able to breathe and be able to function and work in a cohesive way and carry the day-to-day activities of the body. The heart is the size of a fist, or an average fist of a person, sitting somewhere a little to the left of our mid-chest area. It beats at the average of 60 to 80 beats per minute. It carries some millions of liters of blood flow to our organs on a daily and yearly and lifetime. It beats some 3 billion times in our span of about 60 years. And it works somewhat independently of any other organ. It can almost live independently as long as it's provided some oxygen. It can beat on its own, and it can function on its own, and it can accommodate and go up and down to just deal with the demands of the body. We are able to bring blood flow from the heart to all the tissues, to some major arteries. Aorta is a large tributary of what's coming out of the heart, and it goes through the ascending aorta and descending aorta and abdominal aorta, and then it bifurcates into different sections, supplying the upper extremities, the abdomen, the chest, and the lower extremities of the body. It operates by a series of gravitational as well as a series of pump functions to sort of circulate the body's blood flow. It brings in, through the same pump function as a pressure gradient, pushing the arterial or the oxygenated blood through. It forces the venous blood to come back to the heart through the same pressure mechanism. So as it's pushing the fresh blood through our arteries, it is also pushing along and forcing the deoxygenated blood to come back to the heart, to the right side of the heart. When the deoxygenated blood comes back to the right side of the heart, then it carries through two major venous systems, superior vena cava and inferior vena cava, that sort of collect the used blood or deoxygenated blood from the upper extremities and the head and neck and the chest through the superior vena cava, and then it brings in the deoxygenated blood and the used blood and less through the lower extremities, through the inferior vena cava. It enters through the right chamber of the heart, through the right atrium, and through the pressure gradient it falls through and it goes into our right ventricle. After it goes through our right ventricle, it goes down, and through the same series of pumping and vacuum system, the blood is now pushed along through into our pulmonary artery. And our pulmonary arteries is where the blood becomes oxygenated to its maximum possible. Pulmonary arteries are basically an exchange, a transfer that will bring in the used oxygen or less oxygenated blood to our lungs and allow the lungs to exchange oxygen and remove carbon dioxide and other poisons. So the having a good functioning lung becomes a partner for a good functioning heart in order to create an oxygenated blood and be able to now, through the oxygenated blood from the pulmonary artery to the pulmonary capillary systems, coming back through the pulmonary vein into the left chamber of the heart, now becomes the higher pressure system for the heart. So as the blood that is now somewhat more oxygenated, going from 50, 60, 70% oxygen capacity to 80, 90, 100%, 99%, depending on the functionality of the lung, is now in the left chamber of the heart. As it squeezes again, it pushes the blood flow through the left atrium, going down to our left ventricle, and through the left ventricle, it is now squeezed again. The function and creates a higher volume and higher pressure, and forces that volume of blood into our aorta. The aorta is now sending the blood flow, now completing a small cycle through the aorta. We are now feeding, as soon as the aortic valve closes in between the beats, is when the heart takes its own breath. The oxygenated blood is now supplying the heart muscles. So through that oxygenated blood that supplies our heart muscles, we are now able to keep the function of the heart going. So through this closed system, if anything doesn't function properly, whether it is a oxygenation of the blood or it's the muscle of the heart that is not responding to the request for the beat, the problem starts to fail. The electrical activity of the heart is somewhat as complex and as simple as the loop of the blood flow. In the right atrial area, there is some pacemaker, natural pacemaker of the right heart, of the heart in general, is initiated, and through that single pacemaker, it's supposed to carry that fired signal down a path called the bundle of His, down from the atrium to the left atrium at the same time, to the right ventricle, and going down, and somewhat creating a dual pump system, whereas when the atrium contracts, the top squeezes by the top of the heart, the atrium contracting pushes the blood to the bottom chambers, and the bottom chambers now being full stops filling, and the bottom squeezes. So the bottom of the heart, the ventricles are now squeezing. By the ventricles squeezing, it is also creating an umbrella, keeping the blood from backing up into the atrium. So gravity and pressure drops the blood to the bottom chambers or the ventricles, squeeze, and higher pressure closes the valve that connects the ventricle to the atrium and prohibits the blood from flowing back into the atrium, and then also forces the valves to open forward to push the blood into either the right heart, being the pulmonary arteries feeding the lungs, or pushing the volume out through the aorta. Many of the problems that come as a result of lack of oxygen supply to the heart initiate different issues, whether they are electrical issues, or they are muscular issues, or they're blood flow issues, which we'll get to in the second part of this discussion in a few minutes. But the circulatory system is basically able to maintain a pressure, both a systolic pressure, which is the pressure that is attained at the end of the ventricular squeeze. It creates a pressure Usually the normal pressure that we expect at that time is somewhere between 120 millimeters of mercury to 140 millimeters. Some people operate at a less, pressure of maybe 90s, but they still have no symptoms or any issues of being lightheaded or whatnot. But a lot of us carry the same pressure at a much higher pressure of 150, 170, 190, even to the 200s. As far as a systolic volume or systolic pressure you're growing, it's really along all the arterial surfaces, because it sort of carries this tonality and allows the movement, and you can sense the movement. So you expect it to have a very compliant, very elastic set of plumbing, being able to carry this pressurized blood down to the organs that are in need of this oxygen-rich blood. We expect to have a good compliance. We expect to have no stiffening. We expect these arteries to have no blockages, no plaques, and no hardening, and no other diseases that we will touch upon a little later. As the blood goes to each and every one of our organs, it initiates or keeps the engines running. Whether the engine is to filter the blood or put it through the factory and break down all the byproducts of your digestion through your liver, or go through your kidneys and remove all the toxins of your body and be able to filtrate and purify to a better extent the dirty blood and bring it back to a cleaner sense. Or we expect it to go through your spleen and remove all the dead, partially damaged red blood cell or white blood cells or other types of cells from the body. Or we expect it to go to your splanging arteries of your GI system, gastrointestinal system, that supplies your from the mouth to the rectum, and be able to keep the absorption, the moisturization, the salivation, the digestion, the acidification, the breakdown of the different proteins and enzymes to your pancreas and your liver and your gallbladder. At the same time, so the GI tract is doing its function of breaking food, the lung is doing its function of oxygenating the blood, the kidneys are doing their function of removing toxins and poisons and excess fluid and excess chemicals from your kidneys, or many to your endocrine system, which is able to keep a balance between demand sent in by different parts of our body, being our pituitary or being our other signal centers that say, I want more of a thyroid gland, or I want thyroid hormone, or I want more of a adrenal, or I want more prednisone, or I want more, basically responding to a chain of supplies, a chain of requests and supplies and demands and back, fields that are allowing them to negative feedback or positive feedback to keep the endocrine system going. The mind or the brain basically controls a great deal of our cardiovascular system. If we are very calm and quiet and are having happy thoughts, the heart is beating at a very minimum basic rates, it's beating comfortably, it's squeezing, it's relaxing, it's breathing under a normal demand and request. If we start to walk fast, it starts to ask for a faster response. So the nodes of the heart start to fire a little faster, the pumping of the heart becomes a little faster, the volume of the blood coming to and leaving the heart becomes a little faster, and therefore it starts to rev up the engine of the body. If we start to have emotional duress or stress, Also, a similar thing happens as well, which is asking for a higher pressure or higher speed or higher or less compliance and whatnot. So we're again responding to emotional demands of the body. If we deal with people who are doing yoga and relaxing and are able to control their blood pressure and control their mind and control their stresses through relaxation, that will be one of the things that helps stabilize. If we keep our bodies healthy by exercising, by getting it used to being able to rev up, being able to rev down, and being able to maintain an elastic vascular system, that's a good thing. It's enabling us to be able to keep this engine fired up like a very expensive Ferrari or Maserati. Rev it, press the gas, it does its thing, change a couple of gears, and then quietly turn it down. So by doing the exercise, we're allowing this body to be able to push the engine to the max, make sure it's working, take it for a road test, bring it back, and let it relax again. So that's why the importance of exercises in maintaining a good cardiovascular function. Good nutrition is also another one of our good fortunes. If we drink good water, clean water, non-intoxicated, intoxicated water, and clean foods, we're able to feed this engine enough resources to maintain it at a good functionality and good baseline. Unfortunately, due to the fact that we are in a very high-moving, fast society, that there's a lot of stress, we find a lot of heart problems, there's a lot of stress, and there's a smoking and drinking, we find a lot of heart disease, and we find the stiffening of the arteries, and so on and so forth. And when we the lifestyle is just go to work and get in your car and come back, and go in your car and come back, and the engine doesn't get to rev up and become a good, useful, compliant tool that is now able to, on demand,